Everyone, so in this mini video, we're going to be talking about combustion. So combustion really is a chemical reaction where a large amount of energy in the form of heat is released. And if we're looking at it as a chemical reaction, we see that combustion usually is, if we're looking at the conversion between the different forms of energy, it usually is chemical energy. And this chemical energy is in the form of whatever fuel we are burning, and this is converted into thermal energy. Now, whenever you think of combustion, you probably think of flames. Now, for a combustion reaction to take place, flames does not necessarily need to be produced. Flames are produced in rapid combustion, but rudimentary, when we're looking at a combustion reaction, it really is a transformation of energy from chemical into thermal. So if we're looking at the definition of a combustion reaction, it is a reaction that releases energy in the form of heat. And as I said earlier, this is basically a conversion between chemical energy and this chemical energy is turning into thermal energy. Now, whenever I am having a combustion reaction with a hydrocarbon, and when we're talking about a hydrocarbon, we're talking about substances that are produced with carbon and hydrogen, hence the word hydrocarbon, my two products are actually always carbon dioxide and water. So if I'm looking at this combustion reaction right here, I have wood, add a little bit of ignition temperature, and as a result, we get heat. But if we're looking at a combustion reaction, so when a hydrocarbon burns, the products are always carbon dioxide and water. And the reason why the products are always carbon dioxide and water is because for the combustion reaction to take place, well, we actually need oxygen. So this is where the oxygen reacts with the carbon and the hydrogen, and we get carbon dioxide and water as our byproducts. So if I'm looking at this amazing example of a car, I wish it was my car. One of the fuels that we actually have for this reaction to take place is octane, and that's basically a type of hydrocarbon that is found in high-performance cars and Formula One cars. Well, we can see right here that it's always producing carbon dioxide and water, and obviously energy. Now, for combustion to take place, I need to have three key requirements. The first is my oxidizing agent, and my oxidizing agent, based on its name, needs to have oxygen. So most of the time, the oxidizing agent is actually oxygen in gas form. But the oxidizing agent can be oxygen in liquid form or even oxygen in solid form. And we see this predominantly when we're looking at rocket boosters, right? You'll have your oxidizing agent of oxygen in a liquid form, specifically because, when you're in outer space, you don't have access to atmospheric air and you don't have access to oxygen in gas form. So you would have it in a liquid form or in a solid form. So you need to have an oxidizing agent, so something that is going to cause the fuel to burn. The second thing that you need to have is fuel, so the thing that is burning. So things like wood, paper, gasoline, and so on and so forth. Now, it's not enough to have, my oxidizing agent and my fuel. I need to have that initial temperature, that initial burst of energy for allowing that reaction to take place. And that is basically my ignition temperature. And my ignition temperature is the minimum amount of energy that I need for that fuel to ignite. And when we're looking at a combustion reaction, things that, provide that ignition temperature, things like matches, things like spark plugs, all of those things provide that ignition temperature, provide that impetus for the fuel to ignite. So what we can think of this as a fire triangle, right? And the reason why we call it a fire triangle is that if one of the components of the triangle is not met, combustion does not happen. For combustion to take place, I need to have all three of these things together. So 3 things for combustion: fuel, oxidizing agent, and ignition temperature. I have all 3, combustion takes place. I'm missing one of them, combustion does not take place. Now, our categories of combustion, we have 3 key categories. And whenever you think of combustion, you think of flames, you think of heat, and that would be rapid combustion. So rapid combustion is the form of combustion that occurs quickly once ignition temperature is reached. So any mental image that you have of combustion in your head is more likely than not rapid combustion. So candle, right? We light the match, we put it on the wick, we have a flame. That would be rapid combustion. Also, campfire, propane from a barbecue. One thing that we need to realize that with rapid combustion, we will usually have flames, right? Whenever we have rapid combustion, we will see flames and we will have a large amount of energy being released. Now, the next form of combustion is spontaneous combustion. And spontaneous combustion is extremely unpredictable. And what makes spontaneous combustion spontaneous is that the ignition temperature is reached without outside energy. So this means my fuel lights without the use of a match, without the use of a lighter, without the use of a spark. And this tends to happen very rarely in the real world, but there are examples of it. Forest fires and drought conditions. And when we're saying drought conditions, we're meaning areas that are extremely, extremely dry, that hasn't had any rain for a long period of time, and the grass becoming very dry. And you can have conditions with the sunlight, with the angle of where the sun's hitting the ground, that causes the grass to start smoldering. And because the conditions are so dry, it will just take off. Another type of area where we would see this naturally would be actually in coal mines. So what happens when we have coal piles is that we will see smoldering. And the smoldering is just, the lack of oxygen, lack of air circulation happening in the pit, and then the coal, starts being lit, and you'll actually have embers and fires happening, within the coal piles. So spontaneous combustion in coal piles is a serious issue because coal, again, is extremely combustible, and when you have material that is extremely combustible, lighting like this, well, you have uncontrollable flames. And then the last type of combustion is slow combustion. And an example of slow combustion is decomposing food. And this happens over a long period of time. So slow combustion is not a very quick combustion reaction. So that means my fuel is slowly converting and releasing a very, very small amount of energy. Another thing about slow combustion is you're not going to see flames in slow combustion. So when food is rotting, My apple doesn't like burst into flames. No. Over time, it is slowly, slowly, slowly decomposing, and it is actually releasing a very low amount of energy. If you've ever had the misfortune of touching a rotting food source, it actually feels warm because it is releasing a low amount of heat. So again, our three types of combustion: rapid, spontaneous, and slow. Most forms of combustion that you know of is rapid combustion, and the reason why is because you always see flames. Slow combustion is basically not something that was going to produce a lot of energy. It's also, as the name suggests, occurs over a long period of time. And then spontaneous combustion is unpredictable. You have to have perfect conditions for this to take place, and it's because the ignition temperature is met without having to put in outside energy. So this is our mini lesson on combustion, and I hope you have a great day.